Hello, in this video I'd like to talk about the equation of a sphere. So the equation of a sphere with center at h, k, l. So those are the x, y, z coordinates of the center, h, k, and l. And radius r is given by r squared equals x minus h squared plus y minus k squared plus z minus l squared. Okay, so that's the equation of a sphere with center HKL and radius r. And then if the center is at the origin, we've got r squared equals x squared plus y squared plus z squared. So those two equations we actually will be using quite a bit in our course. So let's take a moment to do an example. In this example, we're asked to graph the sphere x squared plus y squared plus z squared equals 4. So in this example, our radius is 2. And so I'm going to go out 2 units in the x and the y and draw a circle, which kind of looks like a perspective drawing there. And then I'm going to go up 2 units in the z. So that's up there, 2, 2, and 2. We'll kind of draw the upper hemisphere as well as the lower hemisphere to that sphere. And of course you could shade, the outer surface of this if you wanted to, kind of make it look more like a sphere. But that's the idea. Okay, as another example, let's show that the given equation represents a sphere. Find the center and the radius. So first of all, I'm thinking that this is a sphere because x, y, and z, we've got 3 variables and they're all squared. So that tells us that we do have a sphere, but what we need to do here is a technique called complete the square. And we'll complete the square to put this in our standard form. So the first step I want to do for complete the square is I want to take all the terms with x and put them together, and then all the terms with y and so forth. So I'm going to write, x squared minus 6x. I'm going to leave a little space, and now we collect the terms with y. So we've got y squared plus 4y, and now I'll collect the terms with z. So the terms with z, we've got a z squared minus 2z. And then over on the right hand side we have 11. Okay, so now for each of these terms, what I'm going to do is I'm going to look at my b term. So the b term is the coefficient that lives on the linear term. So in this case I've got a 6, I've got a negative 6. So I'm going to go So I'm going to look at the b term, and I've got a negative 6, divide by 2, square it, and that turns out to be a negative 3 squared, which is 9. And I'm going to add that to both sides of the equation. Okay, so to emphasize what we just did there, we added that 9 to both sides of the equation. Okay, so let's do the same thing for our b term, our coefficient sitting on the linear term here. We go b over 2 squared, and that turns out to be 2 squared, which is 4. So I'm going to add 4 to both sides of the equation. So just highlight that we did that. And then for our last term here with z, maybe I'll make a little bit more room here. Just make a little bit more room on our paper. So our b term here is a negative 2, so we will take negative 2 divided by 2 squared. That turns out to be negative 1 squared is 1. I'm going to add 1 to both sides, and again I'll just highlight that we added that piece to both sides. Okay, so what this turns out to be, go back to what we have in the x variable, I have a perfect square. This is x minus 3 squared. Okay, and then in y I also have a perfect square. This is y plus 2 squared. And then the same thing in z, this is z minus 1 squared. And on the right hand side of the equation, let's see, I have 11 plus 9 is 20 plus 5, that's 25. And so the center is located at 3, negative 2, 1, and our radius equals 5. Okay, for a last example, I'd like to look at a sphere. It's a bit like a sphere, but it's actually, we've got an inequality in here, so we have to analyze this a little bit differently. So I'd like to look at kind of two sides of this inequality. So first of all, if we were to look at the set of points which satisfies 2 is less than or equal to x squared plus y squared plus z squared, this describes the set of points outside the sphere centered at the origin. So sphere centered at the origin with radius equal to root 2. And then on the other side, if we look at this side of the inequality, so we have x squared plus y squared plus z squared is less than or equal to 25. This describes the set of points inside, right? They're less than or equal to, so this is inside the sphere centered at the origin with radius 5. Okay, so let's try to draw the set of points that satisfies both of those conditions. So first of all, let's draw our coordinate system. Okay, so we've got our x and our y and our z, so that looks pretty good. And let's draw this sphere centered at the origin with radius root 2. Okay, so there's that sphere, radius root 2. And for this next equation, or this next inequality rather, we want the set of points that are inside the sphere centered at the origin radius 5 and exterior to this sphere of radius root 2. So if we go out here to radius 5 and we draw a bigger sphere, trying to go back through the page there and connecting the upper edges and of course our lower edges, and maybe we'll darken in that back edge a bit. The set of points which lives outside this purple sphere and inside the red one, you know, that's all the points here that live inside the sphere with radius 5 and exterior to the sphere of radius root 2.